Alright, here's the COMSOL opening screen. We're going to do 2D axis symmetric. I select fluids and solids here, but we're actually just going to use fluids. Then you hit study, and then you hit time dependent and say done. And I close some things here just so you can focus on what we're actually doing. You right click, hit parameters. This is just a list of numbers. It's like variables in coding. Yeah, I think it's just phrases that mean numbers basically, because you don't have to say units. You can just type them here so it's easier to get to them later. And if you want to, you can just speed up because that's all I'm doing right now. I don't know if I can speed up here. Okay, so after you're done with that, you can start the geometry, which you're basically just building shapes. I don't know why you have to start from very basic shapes, and you move them around using the coordinates. It's different from like Autodesk where you can draw it. I mean, maybe there is a way to draw it, but I just don't know it. So this is why the parameters can be useful, because you can just copy paste them in. That way you're not changing things all over the place. And you can name the rectangles if you want. I didn't really find a need to. So again, you can skip because this part is just doing some geometry stuff. I just realized the object type says solid. I don't know if that matters or not, but I never changed it in our model, so. Oh, so here's the circle I'm adding. You can say to only do a quarter with 90 degrees, and you can rotate it, so that's kind of cool. Here I'm doing kind of like doubles, because then you can go through and make unions, which you'll see. So what I'm modeling is like the cryovial is just a tube. Since it's axis symmetric, everything's going to rotate around that red axis you see. So you only need to do it on one side. For everything in here, it doesn't show up until you click Build Selected, which is kind of an annoying feature of COMSOL. A lot of the times you can change variable, or not variables, but you can change stuff on it and it won't show you on the plot until you click Plot or you hit Build or something. Okay, so now I'm clicking this button up here to make a union. I don't know if unions are important. It helps later, so you don't have to select so many areas, but it's kind of also just a visual thing, so you can tell what goes together. So you can see I just joined the two rectangles at the top to make the cap, and now I'll make another union. What I'm trying to show here is just like a cylinder, so like that's the wall thickness on the right edge. So I'm trying to join it so that the wall is one piece and like the liquid inside is one piece. So that just joined two of them, because you can see it gets rid of the rectangle going across or something. Or maybe I did it wrong. Alright, there you go. Okay, so now in materials you right click, you hit add material, and then on the left side, or sorry, the right side for us anyway, you get this material list. It doesn't have everything, but you are able to use or define, I think, like any properties you want, so you could just choose whatever you think is closest. And you hit add to component, and then you can see on the left side they're just getting added to the model builder. Doesn't matter if you're using it for whichever material, because I'll define it here. Alright, yeah, so you have to subtract from like one material before you can add to the other. So right now everything was added as air, so if I was trying to add something as plastic, it wouldn't let me because it was already defined as air. Sometimes it does that, sometimes it lets you override, so you just have to see. So I made the outside of the tube plastic, that upper gap is air, and then the rest is water. And then again, you see everything is defined as a fluid, so you can't change it until you add something else that it could be, so which is the phase change material. And then here I'm entering in our own values for the properties that are going to be important for the phase change. So you can scroll down and then define those. The transition interval is like a user-defined thing. It's not an inherent property of the material, like in the real world, but then whatever you say it will be in the model, it'll like become inherent to the material within the model, if that makes sense. So in like an ideal system, the phase change would happen over an interval of like 0, but that doesn't happen ever because of impurities and whatnot, as the TAs explained it. So we're choosing 5 for ours just because 10 is pretty wide, 1 is pretty narrow, 5 sounded good, and we'll just keep it consistent between models. And then thermal conductivity, density, heat capacity are just things that you can find online. Most of them came up how I wanted them for water, because that's what like the material is already set as. I don't really know what the ratio of specific heats is, it's hard to find online, so yeah. And then phase 2 for us, I'm using the properties of ice. So even though the material says water, the thermal conductivity, density, heat capacity that I'm entering are for ice, as we found online. And then ratio of specific heats, I'm just keeping it as 1.1. So now we need to add, oh, just kidding, getting rid of that one. Oh, we do need to add stuff, but I forget when I go back. You can just pick whatever time range you want it to be. It's in seconds, so just remember that. And then initial values, since this is a time-dependent study, that's just what things will start as. And then you can add other factors that will like make it change over time. So I'm setting the whole tube and contents to start at like room temperature. And then here I'm adding a temperature, which, as you can see, it says T0. Or at some point you'll see an equation T equals T0. So for all time, whatever you set to be that temperature will always be that temperature. So if you over-defined everything to have a set temperature, nothing would change over time. The mesh, I just keep it at whatever it gave me. Then here's this error because gamma isn't defined. As I said, that one's kind of weird. It's strange to me that the materials don't come with it defined, but when I open it, it comes in as one. So now when I compute the study, temperature does not change over time because I forgot to add a boundary in the temperature, so that's what we go back to do next. But you can change the time to show you the, I think it's the surface temperature at different time values. In COMSOL 3.0 or 3 point whatever, it actually shows you over time. It'll have the time just increasing and the colors will change on the graph, so you don't have to go through and select it. So now I'm putting the temperature boundary as the outside, which means that the outside of the tube will be -80, which is my defined freezer temp for all time, and that's what's going to cause the rest of the tube to change temperature. So now you can see that it changes. The scale is really annoying in COMSOL because it'll just change based on whatever. Here you can see it's 192 to 193, but now it's 200 to 290, which is a much greater change, and like the colors, it's kind of frustrating, but you just make sure you look at the temperatures defined on that color scale. Now I'm putting a cut point so that we can make a graph. So again, you have to hit plot before it'll show you anything, and you can see that it's way down at the bottom. I'm just going to move it up. So there's our cut point. It's defined under data set. You had to right click data set and then choose cut point. You can right click and choose plot group. And now I'm going to select that I want the data from that cut point. And it's not plotting right now because I'm in plot group, which I need to add a plot to the plot group. I'll do that in a second. So if you right click on plot group, you can say point graph and then choose the data there. Now it should work. So you see there's this phase change area where the temperature is nearly constant, and you can actually use this little tool up here where you can zoom in on a certain area, which is pretty nice. So you can see over time the temperature is decreasing, but in that one region it stayed the same because energy is being used to change phase. Now I'm making another cut point and it'll show me where I plotted it. It's at the same place right now. This is, I think, too far away, so it gets a weird graph. Yeah, so that point is like way out there somewhere, so I gotta change it. There we go. And then I think I add another one here that's a little bit farther out. And I typed the wrong thing again, so. So now we have 3 cut points plotted, and then you can go through and use those to show like change over time. So now you add some more point graphs and you define what the data set is. I'm not totally sure what the point graph is in itself because they each show all 3. I usually just click on the 1D plot group once you've added the point graphs. And then here I think I just mess with the time to show you that you can. So I said take 1 data point every 60 seconds or I think 100 minutes. Is that 1,000 minutes? And then in the graph, oh, yeah, so it got really cold. In the graph, you can't see anything because so much of the time was spent already at -80. So then I go back and I change it. But 60 seconds I think is too large of an increment, so this still gives a graph that isn't quite what you want to see. So yeah, you can't really see the phase change, probably because the time step is too big. So you can make the time step smaller. And then now you can see a phase change. And this is different from the time step at 10 also. It doesn't show you the legend like I would like it to, but that blue line is the innermost point. And then now I'm looking at the time that the phase change happened so that we can see the temperature graph at a time that's interesting. So at this point, the air is cold and the tube is cold, but the liquid is still not frozen yet. Yeah, so a lot changes between 90 and 95, it seems like, temperature-wise. And then if you want to save the picture, you can go in here. Make sure it's clicked include title, color legend, etc. Otherwise, it's kind of useless without that scale of what the colors mean. So I'm just showing how you can output some stuff. And then this is what you get. Another thing you can output is all the data points, which is, basically what's shown on the graph. So you go export, right click, and then you can choose some data from each cut point. I don't know if there'd be a way to do them all at once. And here's a text file. It comes up pretty horizontal, which is strange. There was a section where it asked you what kind of data, where it says spreadsheet data format. You can change that to say section, but then it's also kind of strange, so whatever works for you. Here I'm just playing around. I'm adding another temperature boundary. This one I'm setting to be hot. And then for the boundary I'm putting it as like the surface of the liquid. I don't know what this would represent like in real life, but just to show how the temperature kind of works. So I have to remove, oh, okay, there we go. Yeah, so that's just the surface of the water. It doesn't represent anything. Like in real life, this is just an example of what you can do with a model. Alright, so now you see the surface of the water is hot the whole time, even when the rest of the tube is cold, because